Hey everyone. My understanding is it is now 3:50 and we can get started. So welcome. My name is David Burrell and I manage dev tech at Meta for Reality Labs, so formerly known as Oculus. Been here 10 years. Been doing kind of SDKs, samples, and tools the whole time. But yeah, I'll be talking to you with my colleagues Neil and Alexandre today about performance, Quest capabilities, some of the differences between Quest and other game development targets. How many of you develop for PlayStation or Xbox? Okay. And yeah, we'll be talking about some of the differences there, and also getting into the nitty-gritty of some of the things you can extract from the system. So there are some fundamental differences between VR and other platforms. There are also differences between mobile devices and tethered devices, we also provide a number of middleware, tooling, and reference solutions that can help accelerate that for you. But we think that the potential is very high here for revenue and engagement. So I'll be talking a little bit about our understanding of that and how you can learn from others' experience. So first, let's start with an overview of the system. Quest, as we know, is a standalone mobile VR device, Quest 3 has mixed reality capabilities. We're running on essentially what you would find in an Android phone with some custom silicon for VR purposes. But this may look familiar to those of you who targeted Android. There's a Qualcomm processor. It's an XR2 generation 2. And we are pushing about as many pixels as the PlayStation 5 on average. But there's about 1/10 the power available. And as an app, you're running with a goal for maximum immersion, but also maximum battery life, and actually fan noise being minimized because the thing is literally strapped to your face. So these are all things that you don't run into on PlayStation as much. You can run the fan up to a much louder airflow level. We also have a lot of CPU power, and the GPU is twice what it was on Quest 2, actually more than twice. Software, this is changing all the time, but we're running Android 12. Vulkan is our preferred graphics API, but we also support Glass 3.2. And Unity, no surprise. Actually, how many of you are Unity devs? Most of you, as usual. And how many are using Unreal? Yeah. Well, yeah, we support Unreal 5.3, and we actually just announced last week support for Godot. So there's another engine that is already basically functional on OpenXR, but we're investing in making that work well too. So you can use a variety of workflows there and get kind of different trade-offs. But compared to a console, and by the way, iteration time is not great on consoles. How many of you are working on a project where an edit, compile, test iteration on device takes more than an hour? Less than I would have thought. That's actually pretty common. On our device, it's not a lot better. It's actually worse in some cases. But on top of that, you have to take the headset off and on all the time, which adds quite a bit of friction. So we have a couple of ways to help you avoid that, but that's one immediate workflow difference. You also have to spend a lot of time optimizing performance. VR, especially mobile VR, is often the most demanding performance target among all the different build targets that Unity and Unreal support. So not only are you maximizing visual immersion, pushing more pixels than most other situations per second, you're also operating, as I said, on 1/10 of the overall power consumption, and you have to think heavily about stability of frame rate, because successive dropped frames, as we'll talk about later, will hurt your app's popularity. Unmapped design space is a problem. There's a new user interface, kind of paradigm being established here. Having a computer strapped to your face, you don't have the constrained motion of a mouse. You don't have the high bandwidth input of a keyboard unless you're using our relatively recent, tracked keyboard or virtual keyboard solutions. So realistically, you're going to be innovating quite a bit, and that can have surprise costs for your schedule. So how does this play out in content? Well, on the plus side, there's a lot of things you can do. We've talked a lot, for the last 10 years about presence and how, spatial understanding can maximize the emotional impact of your content. We know that, people, seeing stereopsis and having, tracked head movement with the fidelity that we provide, it can make you really feel like you're present, subconsciously in another place. That's powerful, but so is the fact of the increasing freedom. As you have an untethered headset, the ability to move freely around up to an arena scale, as Carmack used to say, space. And as Palmer alluded to recently on Twitter, neck torque is an important metric, and we are constantly improving it, especially with the Quest 3. And yeah, as I mentioned, the displays are always getting higher and higher resolution, and so are the render targets that the GPU can support. So these things, will, measurably improve, users' experience and retention, as I'll get to later. But there are other factors as well. And one thing we've recently been making a lot of progress on is your sense of embodiment. So this means, the ability to feel like you're actually physically present with other people. This is also a powerful emotional factor in experiences you can build. So we all have mirror neurons and motor neurons, but we have empathy for embodied emotion in others based on their body language that you can actually render and capitalize on quite a bit in VR. And our movement SDK recently added leg tracking, although that's using inverse kinematics. We're able to fuse a number of sources to provide plausible and empathic characters. I also want to point out that, so who here only develops mobile, like AOSP or web? Okay, we have a few people. So this is actually a very large cohort of developers, and I want to point out right now that you can make VRC passing apps this way right now. You have to make a complete environment, so either use pass-through, 360 photos, or use a GLTF environment or so on. But you can write panel apps, both using HTML5 and AOSP paradigms today, and leverage your mobile skills. So that can be really a great way to write a mobile app, mobile media player app, for example. So here's an example of a WebXR app. So this is written in A-frame, but it's able to toggle between a 2D and a 3D paradigm. And so you can use what VR is good at for that, but then also benefit from the traditional 2D paradigm. So a lot of things contribute to engagement, but let's take a look at the first thing we always harp on, which is frame rate. So if you have successive dropped frames, and this is an unnamed app, but this is a real app. So this app unfortunately suffered a regression where it started successively dropping frames more often. And you can see a steady decline in its engagement as a result of that. Similarly, and more generally, comfort, which is a more general case of dropped frames, which are a specific form of discomfort. Unrealistic locomotion can cause discomfort and attrition from your app. So here's another example of user feedback for returns on another unnamed app, that this is real data, where unrealistic locomotion led to user nausea and returns. And this is not an isolated case. And as I mentioned, social presence, being with other people, is something you find in many of our top selling apps. It's very common that people get into the headset to meet with each other, and so multiplayer is something to consider. Here are a couple of factors that do drive retention, and you'll see that a sense of emotional connection to others and co-presence is an important factor there, just as much as visual immersion. And now I'll hand it off to Alex.
All right, working faster, isn't that the dream? Like, basically being able to iterate and test out your ideas and improvement faster and with less wait time. Let's first talk about tools that will help you author your projects faster. I'm Alexandre Sivierge. I'm an engineer on the developer technology, and I've been focusing mainly on developer velocity. First tool is MetaQuest Link. It's a tool that basically, the main problem when you develop for Quest is building and deploying to your device. That can take a lot of time. So with MetaQuest Link, you can connect your device to your PC and test out your application directly from the editor using your normal PC development flow. How many of you have used Link in the past? Yeah, cool. It's the majority of you. So with Quest Link, you can use either cable or AirLink. AirLink is really useful when you have to do mixed reality, if you have to walk around a bigger room and you don't have a long enough cable. And now we can easily toggle it with MetaQuest Developer Hub in the Device Manager section. You can also go into MetaQuest Link app on your PC and toggle which feature you need, like pass-through and spatial data. It's very powerful to test out gameplay changes as well as content and test out inputs like controllers and your hands. Announced last year at Connect, we have Meta XR Simulator. This is changing how we iterate on our project. You probably heard about it earlier today, but let's go over a couple of things that makes this very powerful. As David mentioned earlier, dawn-off is probably one of the most necessary but really frictious aspect of testing on your headset. With Meta XR Simulator, it's a full simulator on your PC without the need of a headset. You can also now test out with using your controllers with a connected headset to your computer without even having to put it on your head. And like Link, you can use your full editor process as so. It's also very powerful for mixed reality. As we have now 3 synthetic environment that comes with it, where you can test out features like pass-through spatial anchors and shared spatial anchors. And we also have just released Environment Builder, where you can build your own set of rooms to test out different aspects that will be necessary for your project. Can you imagine being able to test small to big room, empty to cluttered, without having to move from room to room or rearrange your furniture for mixed reality? That's super powerful. Now that we have tools, how do we use the features? That's where samples comes in. We build samples so that we can demonstrate how to integrate different features together and also help you visualize what would be the outcome of building with those features. Let's go over 2 of our most recent samples we released this year. So first one is Cryptic Cabinet. It's a mixed reality showcase developed in Unity. It's an escape room-like puzzle where you can basically solve puzzles to return a cabinet through space and time. What we really wanted to focus on here is one of the biggest challenges of mixed reality, which is how to blend physical and virtual together. In this project, you'll discover how we use the Scene API to really understand the physical space and integrate objects randomly in the room in the right positions. We also use the XR Interaction SDK with the basic interaction to manipulate all the objects to be able to solve the puzzles. But we also expanded to create more complex interaction, like the screwing of the light bulb, opening the drawer with the key, or even the dials on the safe. Also, we demonstrate how to use the pass-through color mapping feature, where we can change the ambiance of the game based on the state. And finally, it's fun to solve the puzzles by yourself, but imagine being able to do it with friends in the same physical room. That's where we introduce co-location. So with the integration of co-location package, you can now have a shared experience with people in the same room. Our next project is Fanto. So as many of you have asked, we released Fanto with a Unity and Unreal example. The main goal here was to show how integrating shared mesh and the scene model together will get you a better and more polished MR experience. First, we have the Phantom that can navigate through the scene in the air using the shared mesh as a sensor. And then if we add a physics collider on the shared mesh, we can collide with physical object in the scene. So you can see how we can have the collision of the particle on the walls here. And using the mesh and the scene data, we can generate a navigation mesh for the little phantoms to walk around. Also, we can place objects directly on physical objects by raycasting to the generated scene mesh. Also, what would be a sample without visualization? So here we can visualize the generated mesh in this project. It's available on GitHub for Unity and Unreal, and you can make it your own. We have many more samples on GitHub. Each of them are targeting different challenges that you may have right now or in your future project, and hopefully they also inspire you for your future projects. Now let's talk about optimization. How do we make our app better? Let's go over some few best practices that should give you a good foundation for your next project. The project setup tool that is available with the Meta XR Core SDK for Unity, and when you integrate the Meta XR plugin in Unreal, will help you set up your editor to have the best for Quest. Next is how to fastly iterate using for gameplay with Meta XR Sim or Link, and iterate graphic and performance directly on your device. It's important for MR to test different scene scenarios. That's where XR Sim can be super helpful, but also testing them in real life because every user has a different setup. If you have occluded objects in your scene, in terms of design, it's really good to have an affordance system that really indicate to users where to look because they can often get lost in VR or even MR with occlusion. So having that either visual or audio or even both is really helpful. Talking about audio, designing audio, having a design of audio early will help your project be more immersive in the long run. And finally, testing performance often is really useful. Testing from the beginning will help you figure out the hiccups early and will save you time in the long run. And also for performance, always test directly on device, as that's what will give you the best result. And now talking about performance, here are some tools and a flow how to use them. So if we want to know, okay, like we have our app, where are the different issues? First, we can use OVR metrics. OVR metrics is a tool that overlays some stats directly on top of your application while you're running it. It's available on App Lab for easy installation of your device. And it's fully configurable, so you can set up which stats you want to see. But in general, let's start with frame rate, which will give you a good idea of where you have some hiccups in your app. Once you figure out which areas, if you're using Unity or Unreal, using those tools is the tools that comes with it. The engine are really powerful to figure out if you have algorithms problem and make sure that you use the right APIs. But if you still have issues, you can use the performance analyzer in MetaQuest Developer Hub. This tool will show you the stats on the CPU and GPU. And once you figure out if you're CPU or GPU bound, we can use the proper tools to dig in and figure out where your problems are. So if you're CPU bound, Perfetto will give you a good idea of what is happening on your frame. From the performance analyzer, there's a record button where it will record a trace and give you the idea of how much time you're spending on your frame. And then on the other end, if you're GPU bound, we can use render.metaphor, which will give you a lot of stats of a specific frame that you can capture. In general, you'll look for different render passes that you don't expect or are taking too much time, as well as how much you're spending on your shaders. With that being said, you can use the QR code to see a little bit more about that flow and the different tools we offer. And I'll leave it with Neil to talk about PeakXR.
Thanks, Alex. Now that Alex just gave you a comprehensive overview of many things, including performance tools, we're going to take a very logical next step, which is to discuss how you all can achieve a PeakXR performance with a key focus on the raw CPU and GPU performance of your apps themselves. And honestly, we'd be remiss if we didn't mention that there is going to be a trade-off space, both in some trade-offs that are just going to be unavoidable. For example, you heard David earlier mention how we are pushing pretty similar pixel bandwidth, just raw number of pixels per frame rendered, to a lot of other platforms that have roughly an order of magnitude more compute. So how are we even going to achieve that? Part of it will come from some trade-offs, but our goal here is to really empower you to understand how to look at those trade-offs to really ship the best game and app possible. So the first trade-off is going to be based on GPU performance, and it's an architectural trade-off of sorts where mobile GPUs historically have always used something known as a tile-based deferred renderer, which is very different than what most PC GPUs use, which is known as an immediate mode renderer. Now, you can read online for a lot more comprehensive of an overview of both of those. We don't need to discuss every nook and cranny here. But if there's one takeaway you should understand, it's that mobile GPUs have memory bandwidth at an absolute premium. And that's why pretty much everything in their architecture, including everything in the render pipelines that your apps are going to use, should try and minimize the memory bandwidth. And that's seen in this tile overview where what mobile GPUs do is they try and minimize the data flow, the data bandwidth transfer from this on-chip GPU memory to what we'll call RAM, which is persistent storage of sorts. Whereas PC GPUs are just going draw call after draw call after draw call, not really trying to minimize that. Instead, a mobile GPU is just really partitioning the scene into a set of tiles, rendering everything for one tile, which could even be 50 draw calls. It could be a lot of work, and only after that's done, then doing the memory bandwidth transfer. So the main takeaway here is that certain effects like post-processing are actually pretty expensive on our platform. They're pretty heavy in memory bandwidth. That doesn't mean you should never use them. For example, our guidance even is that on recent hardware, like our Meta Quest 3, which is a step function GPU, and as David mentioned earlier, you probably want to start looking at post-processing, maybe a pretty interesting effect like a bloom pass. But the idea should just be keep memory bandwidth to a minimum. Now, there's another set of trade-offs we could discuss, which is what use cases of the extra or of the broad GPU space that you can even utilize in your platform. And there's a generally agreed upon rule of thumb, which is that the stronger the GPU is on board, the higher resolution you can render at. This is not obviously a hard and fast rule. For example, even though mobile phones are down there at the bottom in this chart, a lot of newer mobile phones actually have extremely high display resolutions and pixel densities. But it's generally an agreed upon principle that the more GPU you have, the more resolution you should target. What makes VR a little bit unique is that if you think about it, VR covers your entire FOV as a user, which is very different than a lot of these other platforms that really only cover a small subset of your FOV. So a lot of what VR demands is a much higher resolution to achieve appropriate pixel densities for your use cases. And that's why we think a really good decision for how to utilize some extra GPU would just be to up the render resolution, render target output of your apps. And we have a dynamic resolution feature that some of our folks have implemented that we really think almost every developer should be using. It really is just a strict positive win. But there are a lot of other ways to use the GPU beyond just that simple resolution bump. In the bottom left, we have Red Matter 2, which a lot of you might know as one of the titles on our platform that's most known for really rich graphics. And in this case, in addition to just bumping the render resolution, which they did, they also achieved really cool looks that you can tell that there's some really good dynamic shadows in there with PCF 5x5 shadow filtering and really high-res 4K textures. And on the right, we have a pretty recent release in our Quest store called Stranger Things VR, and they were able to achieve a pretty heavy geometry complexity. So the idea is, there are many different ways to skin this cat, and it's going to be up to you to figure out the trade-off space. Some apps are so visual quality bound that they want nothing but resolution, but other apps, maybe you want a better art style, a better look to really spend the extra GPU. So now, maybe it's the most fun topic of all, because we really want to convey the theme that everything that we just spent the last 20 minutes talking about, it's in service of you, the dev, because of a belief that content is what drives the device. Content is what's going to get users to put the device in their face and really spend a lot of time in there. So we're going to discuss some success stories of how a lot of devs have maybe utilized some of these similar principles to achieve a really good Quest launch. So let's start with Asgard's Wrath 2, built by our very own meta-internal Sanzaru studio. And Sanzaru have been VR industry vets several years with several successful projects. And what really stands out in Asgard's Wrath 2 is just the vastness of the open world that's staring at you. And In some ways, this is a really good demonstration of the fact that a really high graphical quality is possible in our platform. And it wasn't easy, though. The team had to be, they couldn't decide a lot of things at the 11th hour. They had to have really early perf budgeting, a lot of checks and balances for how to partition that CPU, GPU, and memory budget along the way through their development. But they're a great success story of what can happen from a graphics perspective. Then you have Assassin's Creed Nexus, which is a recent title that Ubisoft shipped on our platform. And they use Unity as well as a heavily modified universal render pipeline / SRP scriptable render pipeline. And in addition to really good graphics, which they also have, we also want to call out that they're what we call a success story of having used our platform feature named Application Space Warp, which we unveiled a few years ago. Also check out Ben Walker's upcoming GDC talk, where he's going to go a lot deeper into AppSW, perhaps as a good way for any of you devs to understand the integration flow. So the idea here is that even though AppSW does increase maybe the raw latency, because now you're going to be rendering half the number of raw frames and letting our system interpolate every alternate frame, they were able to achieve a really good look, a really polished experience, and they also put a lot of comfort optimization into it to get a really good user experience. The final title we're going to talk about is Walkabout Mini Golf, which is a favorite of many of ours for many reasons. They go beyond just graphics, although we still shouldn't sleep on the really nice art style. And going back to David's table from earlier about how frame drops are negatively correlated with engagement, one of the things we maybe subliminally feel when playing Walkabout is that it's just such a smooth experience. They render it a pretty high refresh rate, very few frame drops all around. So it's just a great example of some of our best principles really applied, and it's a very social game, which ties back to a lot of the previously mentioned ideas too. So the main thing we want to leave you with is that we've given you a full device overview. We've talked about the workflows that all of you devs are going to be going through with iteration, samples, and tooling. And finally, we've given you some deeper, maybe processor-specific considerations. And all of it is just to create that rich user experience and pretty much prove that even though we're in this perf-constrained mobile processor, a lot really is possible. So that's all for today, and we'd really love for everyone to scan this QR code and give us all the feedback we can. We're happy to announce that there's a free Starbucks gift card that comes for anyone who completes the survey, so thank you.
Sorry, we've crept a little bit into the time. Please do walk up to the microphone for any questions. We do have a few minutes.
Sorry, is this thing on? Oh, hello. I actually did have one question about the, so you mentioned specifically PC and Mac. Are there any plans in the future to return Oculus Rift development support to Linux? I know there were drivers in the past that I used to use in my workflow, and they're not available anymore. I wasn't sure if there were any plans to return them at all.
Yeah, actually, I wrote those SDKs back in the day.
No kidding.
I mean, others did a much better job later. But so the Mac support that we offer today is restricted to certain tools which run on Mac. Link does not run on Mac, and probably will not in the near future or on Linux. But RenderDoc does work on Linux, and maybe MetaQuest Developer Hub could be ported to it without too much difficulty. So we are always looking at that. We have a number of our own internal developers who do use Linux. So ADB obviously works. There's full Unity support for Linux, more or less.
Yeah. All right. Thank you so much.
Howdy. Is Play to Device available on Mac? If not, is it planned? Play to Device on Mac.
Right. So on Mac, you can build and run for Android and deploy an APK. You can also run using XR Simulator now. And unfortunately, Link does not yet work on Mac. We don't have any ETA for that, unfortunately.
Okay, thank you.
I've got a question directed at Alex. I think that's your name, right? So you talked a lot about bringing the workflow over to the PC so that you can avoid having to deploy to the headset every time with the simulator and AirLink. I'm curious, is there any plans to go the other direction as well, allow you to bring the workflow over to the headset? So for example, running the entire game engine editor on the headset and having like all the controls for the game around you, and you can actually block out the level like in spatial like that?
We don't currently have this kind of workflow plan. We do have some tools that makes it a little bit easier where we're exploring tools like being able to see the hierarchy of your scene and things like that in the headset instead of having to go back in front from the headset to the editor and back. But it's something that could be explored, yeah.
A couple of things about that. So in like 2016 or so, Unreal did introduce VR Editor, which is still available in a semi-experimental stage. Also, Unity did implement Editor VR.
Yeah. The reason that I'm asking this question is because the Godot engine actually has an Android version, and I don't know if it's actually working right now, but the XR developer of Godot started working on a VR editor for it.
We noticed. Yes. Can you talk to me afterwards?
Yeah.
Thank you.